You spend 20 minutes studying a list of new English vocabulary. You test yourself. You have them down cold. But when you try to use one of those words the next day, it's gone. The memory has dissolved, like it was never there. It feels like a failure of your intelligence. But from a biological perspective, your brain is actually performing perfectly. That lost word is not an accident or a glitch. It is the result of a deliberate, energy-consuming biological decision to erase information. We know what happens when a brain loses the ability to make this decision. People with a rare condition called hyperkinesia have perfect autobiographical memory. They remember almost every day of their lives. But this constant retention leads to severe cognitive overload. Retaining every daily experience significantly impairs their ability to form short-term memories, focus on tasks, or generalize information without being flooded by specific associations. Forgetting is a survival mechanism.
It keeps your mind efficient. To hold on to a new language, you have to prove to your brain that the vocabulary is actually worth keeping. The brain acts like a prediction machine. It filters through thousands of daily inputs, looking for useful patterns. If information goes unused, the brain tags it as low value and prunes it away. In machine learning, keeping too much highly specific data prevents a system from understanding broad rules, a problem called overfitting. Your brain avoids overfitting by aggressively clearing the noise. This diagram illustrates the physical mechanism behind this clearing process, long-term synaptic depression, or LTD. When you learn a new word, the connections between your neurons strengthen. But if you do not retrieve that word, LTD kicks in, actively shrinking and weakening the synaptic bridge between those cells. At the molecular level, this involves literally pulling AMPA receptors, the proteins that catch signals from other neurons, away from the synapse and back inside the cell wall. The physical trace of the memory is dismantled piece by piece. This cellular erasure is constant. Neuroscientists call this intrinsic forgetting, a process where specific dopamine-driven circuits bias your memories toward erasure unless actively stabilized. In your nervous system, forgetting is the default. Remembering is the hard-won exception. Because your biology works to dismantle those newly learned English words by default, simply reading them or listening to them passively offers absolutely no defense against the erasure process. When you forget a word, your first instinct is likely to open your notebook, reread your highlights, or click through a stack of flashcards until the word looks familiar again. This creates what psychologists call the illusion of knowing. Passive restudying primarily activates your visual cortex. Your eyes recognize the shapes of the letters, and your brain signals that the word is familiar. But recognizing a word is entirely different from actually encoding it into your memory. This split-screen diagram highlights the difference. Recognition relies on cues that are already given to you, triggering a shallow, localized response. Recall requires you to rebuild the memory from within, demanding a massive, coordinated effort across a brain-wide web of neural connections. When a memory is newly formed or weak, generating that brain-wide recall takes a significant amount of mental effort. Learners constantly misinterpret this internal friction, that tip-of-the-tongue struggle, as a sign that they are bad at languages. In reality, the study methods that feel the easiest and most productive cause you to forget the fastest. They never generate enough cognitive demand to signal your brain to halt the pruning process. The biological antidote to this decay is active retrieval practice. When you force yourself to retrieve a word from memory without looking at the answer, you aren't playing back a mental recording. You are physically reconstructing the underlying neural trace. Functional MRI scans prove that active retrieval recruits a highly distributed, bilateral network across the frontal and parietal lobes. It is a completely different map of brain activity compared to the localized pathways engaged by passive reading. Standard memory consolidation relies on a slow transfer of data from the hippocampus during sleep. But successful retrieval practice accelerates this timeline, rapidly stabilizing the vocabulary word directly into the medial prefrontal cortex and the surface layers of the neocortex. That temporary, uncomfortable mental strain you feel when you are desperately trying to remember a word is the literal, physical sensation of your brain executing systems consolidation in real time.
Robust memory networks are not built when English is passively put into your brain. They are only constructed when the language is effortfully dragged back out. Active recall serves a double function. While it stabilizes the target word, it also helps you navigate thousands of overlapping concepts. When you try to recall the English translation for a specific idea, multiple incorrect but related words immediately fire up and compete for your attention. To solve this, your prefrontal cortex executes a process called retrieval-induced forgetting. It actively suppresses those competing, incorrect representations to isolate the exact word you are looking for. By forcing your brain to choose the correct target out of a lineup, that specific word is locked into a thick, permanent pathway. It becomes highly resistant to the biological pruning mechanisms that usually run in the background. Active retrieval acts as a dual-purpose tool. It rescues the correct English word from being erased, while simultaneously clearing away the confusing, interfering noise that slows down your speech. Forgetting is an active biological filter. The only way to manipulate that filter is through the effort of retrieval. People who speak multiple languages fluently do not possess inherently superior memory hardware. They simply utilize study habits that override the brain's default erasure programming, forcing those fragile connections to crystallize. You will never achieve fluency by just reading English. You only get to keep the words that you repeatedly force yourself to find.